This is section 2.5, part B, rational functions. The I can statements for this section: I can analyze and graph rational functions, and I can solve rational equations. For part B, we're just going to be working on solving the rational equations. So a rational equation are equations that involve fractions that can be solved by multiplying each term in the equation by the least common denominator, or the LCD, of all the terms of the equation. Remember, when you're done solving these, you do need to check for extraneous solutions. So if we take a look at this first example, we can rewrite this as x over 1 Now we need to find our least common denominator. We have a denominator of 1 for our first fraction and a denominator of x minus 8 for our second one. So this means we're going to multiply everything by our least common denominator, which in this case would be x minus 8. So we're going to take x minus 8, or x minus 8 over 1, to make it a little bit easier to multiply. And we're going to multiply it by each piece. So we're going to distribute and multiply here. And we're going to distribute and multiply here. So this gives us x minus 8 over 1 times x over 1 plus x minus 8 over 1 times 6 over x minus 8 is equal to 0. Now if you notice on the second part after a plus sign, we have an x minus 8 on top. So if we're looking right here, x minus 8 on top and an x minus 8 on bottom, and we're multiplying, so these can cancel. On the left side, we are going to distribute. So if we distribute the x here and here, 1 times 1 on our denominators is just going to give us 1, so we don't have to worry about that part anymore. But x times x gives us x squared. X times 8 gives us 8x. Over here, this canceled. 6 over 1 is just 6, is equal to 0. Now you need to factor this. This is not going to come out evenly, so if you use your quadratic formula or you use the program on your calculator for quad form, you will get that x is equal to 4 plus or minus radical 10. Remember to substitute that back in to check for any extraneous solutions, but in this case, they both do work. So for this example, before we can find our least common denominator, we do need to factor on the left side of the equal sign to figure out what the common denominators are. So we have x squared minus 6x plus 8. We want to see what multiplies to get x squared, which is x and x. We want to see what multiplies to get 8, that when you add you get negative 6. So negative 4 times negative 2 is going to give us a positive 8. And negative 4 minus 2 does give us a negative 6. So if we notice our denominators, we have x minus 4 and we have x minus 2. Those are the two different factors of our denominators. So we are going to multiply everything in our equation by x minus 4 and x minus 2. And we can go ahead and write that over 1 so that we remember that it is on the numerator. If we distribute that to each piece, Now we look to see if we can cancel anything. If you notice, we have an x minus 4 and we have an x minus 2. So on that first piece, we can cancel both. On the second one, we both have an x minus 2, so you are left with that x minus 4. And on the last one, the x minus 4's cancel, you're left with the x minus 2. So if we multiply 4 and all those cancel, so 4 over 1 just leaves us with 4, is equal to, over here we are going to have to distribute that 3x to both pieces, so 3x times x gives us 3x squared. 3x times negative 4 gives us negative 12x. And then we're going to distribute that 2 to both pieces. 2 times x gives us 2x. 2 times negative 2 gives us a negative 4. Now we have an x squared, an x, and constants. So we're going to take everything to one side of our equation. So if I combine like terms and take that 4 over, we're going to be left with 0 is equal to 3x squared minus 10x minus 8. Now we need to factor this. We do need to notice that we do have a value out in front of our x squared. So 3 times 8 is going to give us a negative 24, and we have a negative 10 in the middle. So we need to see what can multiply to get negative 24 that will add to give us negative 10. If we think of the multiples of negative 24, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. One side is going to have to be negative. This is a negative 10, so we want the larger numbers to be negative. And if we're looking for the set that multiplies to get 24 and adds to get negative 10, we are going to select 2 and negative 12. But we had to multiply 3 to get there, so if we're solving for x, we will divide by 3. So if we have negative 12, we divide that by 3. We're going to get negative 4. And we had 2. 2 divided by 3 is just going to give us 2/3. So x is either going to equal negative 4 or x is going to equal 2/3. If we do plug that back in, we will find out that x equals negative 4 is an extraneous solution. So our answer, when we write this out, it's going to be x minus 4 and x plus 2/3. So when we pull it out, it will be an x equals a positive 4. When we pull the other one out, it will be an x equals a negative 2/3. But when we plug in x is 4, it will be an extraneous solution. So you are left with x is equal to negative 2/3.